What's up, you data friends? It's Yanis here and welcome to my channel. In this video, we are going to go over a Python test example for interviews, and more specifically, this is going to be an intermediate level test. So we have 5 questions that we are going to attempt to answer in under 20 minutes, which is basically 4 minutes per question. Now, what I suggest that you should do is that you should download this file from my GitHub page, come down here and attempt the test yourself, and then you come back to watch the video and see how well you've done. Right, and before we start this video, let me just say that if you're passionate about data analytics and data science, then please consider liking this video, subscribing to my channel, and enable notifications for my future videos. Right, starting with our raw data, when you get invited into a Python interview test, they will either give you the data in the form of Excel, let's say, and you're going to have to know how to load the data in, or they're going to have the data already loaded in the UI they are using, and you're going to have to start answering the questions straight away. In our case, we have 3 Excel files that we are loading in, and if I run them quickly, the first file has some car information, which is basically retail price, invoice price, body size, and body style for these cars you see over here. By the way, this is the top 5 rows. We have a lot more data. And then if we showcase the other 2 quickly, so if we add one more and then one more, and then we showcase car info.head. So this one has some additional information about the cars, and as you can see, index is our key column that we can use to join the data together. And then the third raw data file, if I visualize it, .head, click run, you can see that only has the used prices of the cars. Right, starting with the first question we have over here, it's asking us, what is the average retail price per model for 2023? Order the data descending. So we can see that the model exists on our main data frame, retail price exists on our main data frame, and what else do we need? 2023, which is the year, also exists from our main data frame. So we are going to use car data frame down here. First thing we're going to do is that we need to filter our data to 2023. So I'm going to say where the year equals 2023, like this, and then close my square brackets. What is the average retail price per model? So now I have to do an aggregation. So I'm going to do a dot group by. I am going to select in my group by, I'm pressing everything backwards, dot group by. Over here, I need to select the model because it's asking me to show the data per model. So I'm going to copy this, paste it down here. I'm going to say comma as index equals false. Then over here, I'm going to do my aggregation. I'm going to open close, and then I'm going to open close. And over here, I need to have the retail price. So I'm going to copy retail price, paste it over here. I need the average. So this is going to be the mean. And if I test this, I get an error. It says the cart data. What's the P for? Cart data. Yeah, there we go. We have the model. We have the mean retail price, which is the average. And we also want to order the data. So I'm going to do dot sort underscore values. In my square brackets, I'm going to add the retail price, and I also want to do comma ascending equals false. Click run, sort values like this, and there we go. We have the average retail price per model for 2023, and it's order descending. Right, moving on to our next question. It says, what is the total retail price per make and cylinders for all-wheel drive cars? Order by, and then I think this should say descending, order descending by. So it should be order by descending. Right, So cylinders and all-wheel drive cars, if we check our main data over here, we're going to see that cylinders do not exist. They actually exist on the second data frame. So we're going to have to join the two together first. Then we need to condition our data to only include all-wheel drive cars, and then we need to aggregate our data by running the total retail price. So I'm going to say join one, and it's going to be our first join equals, this is our main data set, dot merge, open close brackets. Over here we need to add our second data frame, which is the car info. Copy, paste, I'm going to do how equals, I need a left join, left, and I'm going to join on, and our key is going to be the index, as we have said at the beginning. So if we visualize it quickly, copy, paste, dot head, open, close, there we go. We can see that up until body style is table A, so this is our table A and down, and this is coming from table B and down. Right, so the second thing we have to do is that we have to filter our data to only has all-wheel drive cars. So over here, I'm going to say drivetrain, which is the column that has the all-wheel drive cars. By the way, sometimes on the test, they are going to specify the columns you need to use. But since this is an intermediate test, I'm guessing that they're expecting you to go in the data set and look and find the columns you need to use. So this is why it doesn't specify the column over here. So I'm going to say drivetrain equals, and over here I'm going to add the all-wheel drive cars like this. And now I need to run my aggregation. So I need my dot group by. I'm going to copy it from above here. In the group by, I want to have the make and the cylinders. So make, comma, and then cylinders, which is over here. And then I want to have the total retail price. So I'm going to change this to sum. And then I also need to order it. So I'm just going to sort it, copy, paste, and then run. There we go. We have the make, the cylinders. So we have the make, the cylinders for all-wheel drive cars. So this is our condition at the beginning. And we have the total retail price and also order descending. Right, moving on to our next question now. It says, show the average used prices per model and year for cars that have more than 500 horsepower. So if we check the columns we're going to need, we need the used prices, which is coming from our third table. If I scroll up quickly, used prices actually exist on this table over here. And then we also need to filter out horsepower, which comes from our second table. Horsepower, yes. So what we can do now is that we can either create a new data frame and join all three data frames together, or we can borrow this data frame we have above here, join one, and join on top of it the used prices, which is what I'm going to do. So I'm going to get this now. I'm going to say equals, and I'm going to do a merge on this data frame now, and I'm going to join the used prices. So car used prices from here. I'm going to say comma, and then I can actually copy whatever I have here because it's still a left join and we are still using the index as a key. There we go. So if we visualize it quickly, we can see that up until here, as we said before, is table A. Up until here is table B, and use prices, which is our third data frame that we have joined. The next thing we have to do now is that we have to filter out cars that have more than 500 horsepower. But if we check the horsepower column, you can see it's a text. So we can't really apply an aggregation on it. What we need to do is that we need to clean this first before we run the aggregation. So what I'm going to do now is that I'm going to actually create a new column called horsepower NO, and I'm going to extract the number from the horsepower down here. And the number, as you can see, is the first three characters. So we can do horsepower NO equals, we need to take the horsepower, str, and then take the first 3 characters like this. And let's visualize it quickly to see if it worked. Horsepower, and there we go. You can see the first 3 characters. We also need to do .as type, and then here we need to say float, so we know it's a number, so we can apply a calculation on it. There we go. Where is it? Use price, oh, use price X. Oh, I'm rejoining because I'm running this. That's why I'm creating X and Y. Let me rerun quickly so I don't rerun it every time. So it's this, and then our first join, and now our second join, and now I'm going to run everything in a new cell so I don't rerun my horse and all. And now what we need to do is that we have to run the aggregation. So I'm actually going to copy something from above here and then edit it. So down here, I should have done join 2. Yeah, this is why. So if I do join 2, join 2, and then join 2, correct. Let me rerun this again. So now I can rerun it as many times as I want, and it's not gonna be creating new columns all the time. So this join 2 now, sorry, join 2, I did do join 2, yeah, join 2 equals join 1, yep, that's correct. So first we need to say where horsepower NO in our condition, which is this one, is more than 500. And then we need to group by the data by model. So I'm going to select model. And then year, sorry, we also need year here, like this. As index equals false. And then in the aggregation, we need the use prices, which is use price over here. And we need the average use price, so min. And then we don't need to sort it, but we are going to sort it anyway because it looks nicer. Sort the data by use price, like this, click run. Join 2 is an error. There we go. We have the model, we have the year, and we also have the average use price for cars that have more than 500 horsepower. And the last thing we can do, I think we have a lot of nuns over here. We can just drop these NAs. We can do drop NA. So we don't have all these NAs down here. There we go. So this is a clean data frame that answers our question. Right, moving on to question number 4. It says, show the top 10 models and make in terms of highway fuel economy. So we want to get the cars that have the lowest highway fuel economy that have a retail price less than 50K. So highway fuel economy, if we check our tables, comes from our second table. However, because we have already created join 3 that has all 3 tables combined, we can just use that data frame instead of running another join. So we save time. So I'm just going to print the head of this join 2 so we see all of the data quickly. Let's do head. There we go, and now we can answer the question. So the first thing we should do is that we should actually clean highway fuel economy because we cannot aggregate it / order it, use the minimum on this text. So we have to extract the first 2 characters from this highway fuel economy. So what I'm going to do is that I'm going to create a new column called highway fuel economy NO, which is the number. Like this, I'm going to say equals, and then copy paste. This is going to be the new one, the no .str. I'm going to take the first 2 characters, so like this, and I'm also going to say .as type. I want to select float, so I know it's a number, and then click enter. And if I rerun my data frame, you can see that we have highway fuel economy NO now. So we can order it now with the lowest. Next, I am going to apply our condition, which says retail price less than 50K. So I'm going to do this. I'm going to say where the retail price, which is this column, is less than 50K, less than 50K. There we go. And then if I run this, yeah, these are the cars. And then what I need to do now is that I have to apply another condition. So my other condition is that, let me close this. So this is my first condition, like this. And I'm going to say and my second condition now is going to be where the highway fuel economy NO, like this, equals with the highway fuel economy dot min. So the minimum value of the highway fuel economy. So if I run this, we get an error. I'm missing bracket, and the bracket is because this. Okay, I'm missing a bracket over here. There we go. We get nothing. Why do we get nothing? Let's test. Let's do this. Let's just select just a condition of the highway fuel economy. So I'm just going to select this condition and see if we have any data. We have data, so the highway fuel economy number is 10 for this car, and the reason we don't get any data is because the retail price of these cars is actually only 5 cars, is more than 50k. So this approach is not going to work. What we need to do is maybe remove this and get the top 10. So I'm going to remove this like this and keep one condition, which is the less than 50k, and then I'm going to order this data. So let me get the sort values like this, and then paste it over here. I want it to be ascending through, and then I want this to be by retail price. Let's check. Sorry, not retail price. I want this to be by highway fuel economy NO. There we go. Let's check highway fuel economy. So 18, and then we can do the top 10 now. Dot head and then 10. So this is the top 10 to answer our question. Click enter, and now we have these cars are less than 50k. That's correct. And the least highway fuel economy for these cars less than 50k starts from 18. So you can see all of them have 18. So this is basically answering our question, which is showing the top 10 models. And oh, it's only models and make. Sorry, another mistake. We only have to select here models and make. So we have to do 1, 2, 3 columns, and I'm going to select model, make, and then also the highway fuel economy NO. Like this, click enter, there we go. So we show the top 10 models and make in terms of highway fuel economy minimum that have a retail price less than 50k. There we go. Right, and the last question says show all the cars that do not have used prices data. So basically we want to show all the data from table A that does not exist in table C, because table C has the used prices. In order to do this now, I'm just going to select my first table, which is this one, and I'm going to select everything where the index, let's say, so index, let's say index, like this, dot is in, and then I'm going to select the unique indexes from table B, which is called car use prices, like this. And then to get the unique, we have to do the index. Can we apply the condition here? I'm testing now. Dot unique, like this, and this is giving us the unique indexes from table B. Let me test. There we go. It's an array, which works. And then instead of saying is in, we want to do is not in by adding this symbol over here. So what this does is that it's selecting all the data from table A where the index is not in this list over here, and this list has all the indexes from the table that has the used prices. So if I run this quickly, you can see it works. All these cars, they do not have a used prices data. And this is the last question of our test. So we have answered all the questions. I think it took us more than 20 minutes, but it's because I was explaining the questions whilst answering them. When you attempt to do this, it should be fine to finish under 20 minutes. If you think it's too difficult, then maybe you can try the previous tests I have done. This is, I think this is an easy one. Sorry, this is a junior one, and I also have a beginner one. If you found this test too easy, I'm going to be uploading another test, which is going to be a difficult one, so you can try that one. Let me know in the comments below how much time it took you to complete this test. And also, if you found this video helpful, then please click the like button, subscribe to my channel, and enable notifications for my future videos. Thank you very much for watching this, and I'm going to see you in the next video.